Aloha everybody, this is Gigi from Kauai Community College. In this video, we will be talking about graphing by transformation, and this is part 3 of graphing by transformation, and we're looking at stretching and compressing a graph horizontally. All right, let's see how this works. All right, so suppose you have the function g of x is equal to square root of 2x. Well, when looking at that, we know that the parent graph that we need to look at is f of x is equal to square root of x. That's the most basic parent graph. And we know the square root parent graph looks like this, right? How does it go? Square root of 0 is 0, okay? Square root of 1 is 1, so over right 1, up 1. Square root of 4 is 2, so over right 4, up 2. Square root of 9 is 3, so right 9, up 3. And there is nothing on the left because when you take square root of a negative number, you're not going to get a real answer. And we know from previous lessons that the domain of square root of x is anything greater than or equal to 0, right? So here is your parent graph of square root of x. Now, how does the 2 inside the square root affect the graph? Well, from the previous video, we know that if the 2 was outside, it is going to stretch vertically, okay? But here it is inside. So inside is going to have a horizontal effect because it is changing the x value, okay? It is changing the x value. So it's changing the input, right? How does this look? Let's compare. Instead of right over 1, up 1, we are only going over 1/2, but the y value stays the same. The x value is half as much. The y value stays the same. Okay, does that work for the next point as well? Normal is over 4 up 2. New point is over 2 up 2. The y value is only half as much. The x value is only half as much. Okay, the fourth point here is 9, 3, because square root of 9 is 3. Here in the new graph, we are only going over 4.5 up 3. So the x value is half as much. Okay, now if we think about this, g of x is f of 2x, right? We are changing the input. Okay, now how does that affect the graph? We knew from the previous lesson that when we are changing the x value, meaning inside, we do the opposite, right? So what is the opposite of multiplying by 2? Dividing by 2, or we say multiplying by 1/2. So here we have a horizontally compressed graph because the x value is only half as much as what it was originally. All right, now, so if you think about that, this graph here, it is on the other side. Okay, how does it, instead of flipping, we're rotating, right? So instead of flipping our original square root of x, we are having f of, this right here is f of, actually, that's g of x is actually f of negative x, right? So how is this going to change the graph? Well, the x value got changed. The x value got rotated to the other side, meaning instead of 1, 1, we have negative 1, 1. Instead of 4, 2, we have negative 4, 2. Instead of 9, 3, we have negative 9, 3, meaning the x value is the opposite. It's on the other side. So I will call this a rotation. So the graph, the parent graph of f of x got rotated to the other side when negative is multiplied to x inside. All right, now, what if you multiply by 1/2? Well, we saw multiplying by 2 horizontally compressed the parent graph. So multiplying by 1/2 would horizontally stretch the graph. Okay, so how does that work? Here we go. Normal, we have 0, 0 is normal, right? So we were supposed to normally go over 1, up 1. But here, the nice point is over 2, up 1. Why over 2, up 1? Because we are stretching the graph horizontally, meaning the x value is being multiplied by 2. Then here, the next nice value for the normal graph for the parent function is over 4 up 2. We now go over 8. Okay, so we now go over 8 up 2. It is twice as long as what's normal. Well, where do you think the next nice number is? Well, normally the parent graph would be 9, 3. Here, we are horizontally stretch it by a factor of 2. The opposite of multiplying by 1/2 is dividing by 1/2. Divided by 1/2 means multiplying by 2. So here we're multiplying the x value by 2. Okay, so instead of 9, 3, we will have 18, 3. And there's that point. And that's how we horizontally stretch a graph, by multiplying the x value by whatever the reciprocal of this factor is. Okay, because inside we do the opposite. All right, now let's take a look at this function here, and we're going to put it all together. Okay, when looking at that, we know that the parent graph f of x got shifted left 5. Okay, left 5. Oh no, what happened? All right, here we go. Sorry about that technical difficulty right there. We know right here that plus 5 will shift left 5, minus 4 will go down 4, and then we are going to horizontally stretch by a factor of 2, and then here we are going to vertically stretch by a factor of 3. All right, let's see if we can go and do this all together here. Maybe I will go ahead and plot the parent graph first. Parent graph goes 0, 0, over 1, up 1, over 4, up 2, over 9, up 3, because the parent graph is f of x is equal to square root of x. Okay, now the new graph is going to be going to the left 5, left 5, down 4. Oopsie, I didn't leave enough room. Left 1, 2, 3, 4, 5. So we are going left 5, down 1, 2, 3, 4. And we have the new vertex is right here. Okay, so left 5, down 4. Horizontally stretch by a factor of 2 and vertically stretch by a factor of 3. So normal is right 1, up 1. Okay, now we are going to go right 2 because we are going to horizontally stretch, right? So new is going to be right 2, up 3. Horizontally stretch by 2 and vertically stretch by 3, meaning multiply the x value by 2, y value by 3. So I'm going to go over 2, up 3. Okay, and normal is to go right 4, up 2, because square root of 4 is 2. Now I am going to go right 8, meaning twice as much because we are horizontally stretching it, up 6 because I am vertically stretching it. And I'm going over and up from my new vertex, and my new vertex is at -5, -4. Okay, so we're going to go ahead and go right 8, up 6, 4, 5, 6. Okay, and then the next point over, normal, is to go right 9, up 3, because square root of 9 is 3. The new graph, though, we are going to go right 18, up 9, because we are horizontally stretching by 2 and then vertically stretching it by 3. So if we were to go from -5 and we are going 18 units over, we're going to end up at 13, and we're going to go 9 unit up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 unit up. And here is our graph. And you can see that the red is being moved, shifted left 5, down 4, and then actually stretch horizontally and then stretch vertically. And that is how horizontal stretch or compress work.